Welcome to The Explainer. I am absolutely thrilled you're here today because, well, we're about to put on our detective hats. That's right, from here on out, consider yourselves official data detectives. Today, we're going to unlock the secrets of KSSM Form 2 Mathematics Chapter 12 using some really powerful concepts. We're talking about measures of central tendencies. I know, it sounds like a mouthful, but I promise you by the end of this explainer, you're going to be reading data like a pro. Let's dive right in.
All right, let's take a quick look at our roadmap for today. We'll start off by meeting the big three. Then we'll tackle extreme values in data. After that, we are mastering group data, choosing the right measure, making predictions and arguments, and finally, we'll wrap things up with a summary and some crucial exam tips.
Section 1. Meet the big three. So, mode, median, and mean. These are basically your best friends in data analysis. Let's break them down. The mode, that's simply your highest frequency. Think about the most common pocket money amount in your class. Now, a dataset could actually have 0 modes if nothing repeats, or even multiple modes if there's a tie for the top spot. Next up is the median, which is exactly what it sounds like, the middle value. And finally, the mean, which is just your classic average sum.
Now, hunting down the median requires a little bit of physical detective work. Step 1 is actually a huge trap that so many people fall into. You absolutely must arrange the data in ascending or descending order first. If you just grab the middle number from a scrambled list, boom, you've been fooled. So arrange it first. Then, if you've got an odd number of items, that exact middle value is your median. For an even number of items, you just take the two numbers smack in the middle and calculate their average.
But what if you're dealing with a massive frequency table? Well, if your total number of data points, which we like to call n, is an odd number, this formula is your absolute best friend. The position of your median is just n plus 1, all divided by 2. Now, if your n is an even number, you'll need to find the average of the data at position n over 2 and the data at position n over 2 plus 1. I know, it sounds a bit complex, but really, it just tells you exactly which spot in line is holding your middle value.
Moving on to the mean. The formula is pretty straightforward. It's the sum of all your data values divided by the total number of data values. So, say you want to find the average hours your friends spend on the internet. You just add up all their hours, divide by the number of friends, and there you go, you've got the mean. But a quick warning here. Keep this formula tucked in the back of your mind, because we're going to see just how fragile it can be when we level up our detective work.
Section 2. Extreme values and data.
Okay, so what exactly is an extreme value? Well, it's a data point that is just way too small or way too large compared to the rest of the pack. Picture this. You've got a group of students building model rockets. Most groups are finishing in 5, 6, 7, 8, or maybe 9 minutes. But then one group, they take a whopping 20 minutes. That 20 is completely out of place. That, my friends, is an extreme value.
And this perfectly exposes the major vulnerability of the mean. When you drop an extreme value, like that 20-minute rocket build, into your dataset, the mean gets completely hijacked. It gets pulled way up or dragged way down. But the median and the mode, they are completely unbothered. They stay exactly the same, safely ignoring that one crazy data point.
Now let's contrast that chaotic extreme value with a uniform change. Imagine the school cooperative decides to just increase the price of all stationery by 2 ringgit. Or maybe they multiply all prices by 3. Because this change happens to every single item uniformly across the board, all 3 measures, mean, median, and mode, change uniformly in exactly the same way. So if you add 2 ringgit to every price, your brand new mean, median, and mode will all just be exactly 2 ringgit higher than before. Make sense?
Section 3. Mastering grouped data.
All right, you're doing great. Now, when you're dealing with tons of data, like say, measuring the heights of dozens of tiny saplings, you're going to want to organize it into class intervals to stop things from overlapping. And finding the mode in this scenario is incredibly easy. You don't have a single specific number anymore, but if you simply spot the row with the highest frequency, boom, you instantly find your modal class. It really is that simple.
But to calculate the mean for these groups, we run into a little bit of a roadblock. We don't have individual numbers to add up anymore. So the absolute crucial step here is that we have to create a single representative number for each group. And we do this by finding the midpoint. All you have to do is take the lower limit of the class, add the upper limit, and chop it in half. Just divide by 2.
So once we have our frequencies labeled as f and our brand new midpoints labeled as x, we can start solving this puzzle. We simply multiply each frequency by its corresponding midpoint to build out this vital fx column. Literally, you're just multiplying straight across the row. Now, I want to put a massive spotlight on this next formula.
See that symbol? That's sigma, and it literally just means the sum of. So, to find the mean of our grouped data, we take the total sum of our brand new fx column and we divide it by the total sum of our frequencies. And just like that, the grouped data puzzle is solved, and you've got the average height of those saplings.
Section 4. Choosing the right measure.
Let's say we're checking out January food sales at the school canteen, and wow, nasi lemak is just towering over the rest. Now think about it. You can't exactly calculate a numerical average for canteen food. Like, what is the mean of nasi lemak and fried noodles? It makes 0 sense. That makes the mode the perfect and, really, the only choice for categorical popular data. You just look for the crowd favorite.
So let's quickly summarize this decision-making matrix so you know exactly which measure to pick and justify on your exams. You're going to use the mode for categorical or favorite items like our nasi lemak. You'll want to use the median the second you spot an extreme value, like, I don't know, if someone drove from Ipoh to Malacca and it took them 10 hours longer than everyone else. And you stick with the mean when you have a nice, uniform set of data with absolutely no extreme values, kind of like the steady monthly production of palm oil in a factory.
Section 5. Predictions and arguments.
All right, let's set the scene. A teacher needs to pick just one student to represent the school at the zone bowling tournament. Our two contenders, Ramesh and Carol. Now here's the catch. If you calculate the mean score for both of these guys across their last 5 games, they actually have the exact same mean score of 152.
So, I've got a direct question for you. If their mean is completely tied, who gets to go to the tournament? This scenario perfectly proves that the mean isn't always enough to settle an argument. We need another tool in our detective kit to break the tie and make a smart prediction about who is actually going to perform better on the big day.
Let me introduce you to our secret weapon, range. The range is simply the largest value minus the smallest value. If we look at Ramesh, his highest score was 209 and his lowest was 116, which gives him a range of 93. Now Kirill, he bowled an incredible 240, but he also had some massive lows of 75, giving him a huge range of 165. Because Ramesh's range is so much tighter, it mathematically proves he's a far more consistent player. And in a tournament, consistency wins. Ramesh absolutely deserves that spot.
Section 6. Summary and exam tips.
All right, we made it. Let's rapid fire through these crucial exam tips for your revision. First up, always identify the mode for categorical data. Second, arrange your data, ascending or descending before finding the median. Don't fall for the trap. Third, use the sum of fx divided by the sum of f to crack those grouped data means. Fourth, always watch out for extreme values secretly warping your mean. And finally, use range when you need to argue for consistency. So, next time you see some flashy statistic online or on the news, I want you to stop and ask yourself, are they just showing me the mean to hide a massive extreme value? The truth is usually right there in the data, detectives, if you know where to look. Thank you so much for joining me, and I'll see you in the next explainer.